Hey, how's it going? Question here from Dan. He asks basically for some advice with respect to building a multiplayer tower defense game. So, if you've built a multiplayer game before and you have some advice for Dan, please throw it in the comment section below. But I do want to say thank you, Dan, for sending in the question. It's because of you folks watching this video sending in questions like this that I can muse and make these kind of videos. I do have some longer form tutorial content planned, but with my work on Call of Duty, it's been a little bit difficult to have the free time to do that. So in the future, yes, but for right now, I think these short little videos where I talk about the games that you guys are making, that brings me a lot of joy. So let's jump into it. He's saying, hey, I wanted some advice on making a multiplayer tower defense game where we would have weekly, monthly team and prize ladders, and he's trying to figure out a setup for multiplayer. So he doesn't know a lot about netcode or how servers work. He figures that the netcode will be deterministic with server setting positions for, let's say, hundreds of zombies getting shot hundreds of times with players defending the towers. So we're thinking about using Mirror with PlayFab. Does that sound good? I figure PlayFab will hold the user's save files and authenticate them. Will I need another host like Azure to make it work with Mirror, or does that service come with PlayFab? Everything is a little fuzzy. I was wondering if you could clear this up for me. Also, any tips and tricks for lots of objects and data? I was looking at this guy's channel, but a little hard to follow. And do you think I should invest in learning in Unity dots? Okay. Wow, Dan, lots of questions here. I love it. This is going to be an exciting video. And so we're talking about a multiplayer, but I think it's worth pointing out that it's always a decision whether or not we should make a multiplayer game. Multiplayer is obviously a lot harder than single player, and it's not a binary between the two. There's a lot of multiplayer-like elements that can happen between the traditional single player game versus a multiplayer game. So when I'm thinking about tower defense, one of my favorite tower defense games is Bloons Tower Defense, right? This is a game on the mobile app, iPhone, iPad kind of situation. And well, it's a single player game where you play as these monkeys and you fight these balloons, and so you set up your towers and then you push play and then the balloons come in and you see if your towers were well positioned. So that is a single player, I guess, idea for this game. And then I guess the next step I would like to look at would be something like Plants vs. Zombies, particularly the newer incarnations of this game. So with Plants vs. Zombies, again, it's a single player game, but there's a lot of multiplayer elements inside of that, particularly with respect to leaderboards and sort of seeing how your friends compare to you. So while you're not, I don't think there's an element of Plants vs. Zombies where you are literally planting down plants at the same time your friend is. You do compare your score against people who you're Facebook friends with and stuff like that. So we have a lot of those PlayFab-like elements. And I think PlayFab is actually a great way to do that. If you could link into something like their Facebook, that would be really good, because then you have a way to interface with their social graph. And, of course, you're going to be way better off if you could say, hey, your friend Bob is better at the game than you, right? That's going to inspire people to work a little bit harder than just to say, you are in the 10th percentile versus, who knows who's competing against you. So it's helpful to kind of show them the friend Bob and say, hey, go beat Bob, right? So that's always useful. And PlayFab actually does a really good job of doing that, to saving the save data. However, it sounds like you want to do something a little bit more detailed. So even something like PlayFab actually might work for the first kind of so when you come into multiplayer, there's different kinds of multiplayer too. Separate from this sort of idea of leaderboard player stat tracking, there's this idea of a synchronous multiplayer versus asynchronous multiplayer. Synchronous and asynchronous. Synchronous is when it's sort of like a live multiplayer game where you see them fight you at the same time. So a good example of this would be Clash Royale. When I put down my minions, they're immediately going to fight, and then I can see the enemy puts down his minions, and then they go and they fight in the middle. Whereas an asynchronous multiplayer game, probably one of the most well-known tower defense games of all time, Clash of Clans, same company, Supercell, that game, you set up your base, and then people can come and attack you whenever they want, right? You don't even need to be playing the game. It could be, your phone could be off or in your pocket, and then someone can go and invade your village and fight against your tower defense setup. So that would be asynchronous multiplayer, and it might be a better fit for your game. I'm not sure. It sounds like you want all these zombies coming in at once, and so me and you, let's say me and Dan, are inside the a server room, and when all these zombies are coming in, we can see each other placing the towers down. Okay, so that would be an example of synchronous or live multiplayer. And that is probably a little bit harder, but even then we have additional questions we have to ask. So now that we know we want it to be synchronous multiplayer, the next big question is it going to be a dedicated server, or is the client going to host the server? Where that is usually called having a master client. So a server is basically the decision maker in a multiplayer video game. The reason why you need a decision maker is because of lag. And so there's a possibility that two different clients, two different players, could try to do something that it's not possible for both of those actions to resolve. Here's an example. Let's say we're playing a tower defense game with all these zombies on the map, and I say I want to put my tower at position 0-0. Okay? I push the button to spawn my tower there, but you chose to spawn your tower at position 0-0 at the same exact time. So whose tower gets spawned there? I didn't yet see yours spawn, and you didn't yet see mine spawn, and we tried to both spawn ours at the same time. Someone needs to be able to make the decision of whose tower is going to spawn, okay? And so that's where we start getting into what is a server and sort of how those decisions are being made. And that server can be separate from the clients, so you can have client 1, client 2, and a third server entity, which would be called a dedicated server. And that server, who knows where it could live. It could live on your home computer. It could be hosted on Microsoft Azure or AWS. There's a lot of places where you could put a server, right? But one of the places that you could put it is on the client itself. So in the process of downloading the game and playing the game, I could also be running a server on the same device. And so in that case, you wouldn't need a separate third entity. You would just have one of your clients a little bit more powerful, and that'd be called the master client. And so he'd have like 0 lag because the server is literally on his device. But the reason why they sometimes don't want to do this is because you can do a little bit of hacking to do that, right? You could fake packet delivery, and so that's a broad statement. But I would say, for your purposes, especially just getting into this for the first time, you should do whatever the easiest thing is, okay? So I don't know what that looks like. It probably depends on whatever your integration is. So for example, I know Photon just kind of sets you up and you don't have to worry about, I think it's probably master client that they set you up with, and it's just like one of the clients is hosting it. Or maybe there's a way that you could pay to get dedicated server, but I'd say don't worry about the differences too much, especially in this early stage. I'd say focus on the gameplay and get that working, and worried about like this lag, that might be the next step after you have like maybe an initial prototype set up. But I do want to just sort of give you a broad span of some of the concerns you might face along the road. Then the other thing being, so we talked a little bit about multiplayer versus single player. We talked about asynchronous multiplayer versus synchronous multiplayer. We talked about, in the case of synchronous multiplayer, dedicated servers versus having a master client. And I'm giving you all these keywords so that you could go forth and sort of research them, give it a Google, try to understand, what does a dedicated server setup look like using, this service called Mirror. Or I'm not familiar with Mirror, but I've used Photon, for example, on Unity, so you could Google that, try to figure, what does Photon master client relationship look like in Unity. So these are hopefully enough keywords for you to get the wheels turning and for you to go do some research there. Eventually in your journey, so let's say you go with a dedicated server, right? So you've got this separate server. So what that would look like is the server is making all the decisions of what's going to spawn. And so you have the two clients, and so let's say I'm one of those clients, and I want to spawn a tower. Well, that would really look not like spawning a tower. It would look like a request to spawn a tower. The clients no longer make the decisions, the server does. So instead, I would just be clicking my button, and that would go up to the server and say, hey, Matthew wants to spawn a tower at the origin. Is that okay? And then the server might say, yes, that's perfectly fine, and then send that message back down that a tower has been spawned. And of course, that message would go to both Dan and Matthew so that both of them can see the tower spawned. Now, that might take a little bit of time, and that could be a little bit frustrating for players, particularly the person who spawned the tower. If I click spawn, and then it takes a second for it to go up to the server and come back down, well, then it'd be a second delay before the tower actually spawns. So that looks like some serious lag, right? That's kind of annoying. And so that's where we get into some of the more advanced topics where we try to combat this lag. And so one of those advanced topics which you're going to learn about in the process of networking is called client-side prediction. So the way a client-side prediction works is we say, okay, if you want to spawn the tower there, let's just assume that you did. And so let's spawn the tower there, at least visually, and then send the request to the server. So you can immediately see the tower there. Okay, but what happens if then it goes up to the server and the server says, actually, Dan spawned the tower at the same exact time and he spawned it first. At least I saw it first. And so now it sends the message back down that Dan spawned the tower there and you did not spawn the tower there. Well, then we have a little bit of a problem, don't we? Because we have the client that has my tower spawned. However, it should really have Dan's tower spawned. So we've predicted the future, but we predicted the future incorrectly. So that's not very good, right? What are we going to do in order to resolve that situation? And that is where we start talking about, there's different ways, right? But one of the ways that it's often handled, particularly in first-person shooter titles, is you would do a rollback. So the idea would be, at any given time, we have a state of the world that we package into a snapshot. And so I'm going to do a little bit of reduce the information here. I'm going to make it a simplified problem. So I just want you to be cognizant that this is not exactly how it works. But the idea would be we have a snapshot that has every position of all the zombies and all the towers. And we say that is snapshot number 1. And then we send up the server information. And we spawned our client, we spawned our tower. So that's snapshot number 2, where it has my tower. And then we go back and we realize, oh no, snapshot number 2 was a prediction of the future, but it was actually incorrect. What should have happened is the new action is that Dan's tower should have spawned, not my tower. And that tower being spawned is the only difference between snapshot 1 and 2. So what we would do is we would then go back in time, roll back the local client to snapshot 1, and we would say, what happened after snapshot 1? We thought Matthew spawned a tower, but that was not true. In fact, with the information we have now from the server, it turns out that Dan spawned a tower. So now we would move forward to snapshot 2 with the correct information, and that would be, of course, that Dan's tower has spawned, assuming everything else didn't change at all. Okay, so what we've done is we've now introduced this concept of saving the state of the world every server tick, and we can go back and forth in time using deltas, which are basically the information of what has changed between one snapshot or another. So the reason why I mention this is because you started to talk about the word determinism, right? So that came up right here, deterministic. What does that mean? What's the purpose? Well, the idea of a deterministic system is this idea that with the same inputs, we can generate the same exact outputs. So if we know the inputs, we know for certain what the outputs are going to be. This is incredibly important when we are traveling through time, because if we go back in time and we send in the same inputs, for example, Dan's tower should spawn here, we need to know that our system will generate the exact snapshot of time number 2 that the server did. We need to know that they're going to be perfectly linked. Now, for this particular game, I don't think it's going to be an issue at all for you, because you just need to reduce the amount of randomness. So for example, if let's say it like this. If when you try to spawn a tower, there's a 50% chance it won't work, right? So I'm adding a little bit of variability here, reducing the determinism. If there's a 50% chance it wouldn't work, then sending me the message that he tried to spawn the tower, well, that's not very helpful, right? Because I don't know whether or not it really did spawn. And now when I try to reproduce the future, there's a chance I might get it wrong, because there's a 50% likelihood that it spawns or it didn't spawn. So this probably isn't going to be a problem for you, because you just have to remove that aspect of it when it comes to a server sending a message. So maybe the server doesn't send a message of whether or not it tried to be spawned. The server could just send a message of whether or not it actually did spawn. So it's going to be pretty easy for you to set up this system so that you don't have to worry about determinism. One of the problems, though, particularly with the Unity game engine, is the Unity game engine physics system is not deterministic, okay? And so that is, I have worked on projects where we had to rip it out and put a new physics system in. Now, be warned, okay? Because I know the first Google result says that there's something like I know I've had a student run into this before, where it's like sorry if I repeat myself here. I paused my recording by accident. But the number one result for like Unity answers is like, yes, Unity's physics system is 100% deterministic, which is not true. Okay, and it's one of the big reasons why people will use third-party physics engines like Havok, which are designed specifically for game dev. I mean, a Unity system, of course, should be, but I don't know. I don't know why they didn't choose to do that. It's probably more complicated. So, what else did we talk about? I don't know if I mentioned it, but you should definitely check out Gaffer on Games. So Gaffer on Games looks like this. Woo. Gaffer on Games. This is a great website for learning more about synchronous multiplayer. This is by Glenn Fiedler, and he has a lot of great resources there. So I would totally read that up. So I believe we talked about. So we talked about synchronous, asynchronous, dedicated, master client, server side, client side prediction. I think we hit everything you wanted, right? So to answer your question, what do you need to do? For this player save data, you would need to have PlayFab if you want. I mean, that's an option, sure. And that could store things like leaderboards. I know I've worked with the PlayFab integration in Unity before, where they have like the weekly leaderboards, and it actually resets automatically. So that's great. That's a really great option. I don't think I have a PlayFab tutorial, but I probably should make one at some point because their API is a little bit hard to understand, but it's a great system once you get the hang of it. And what's the other thing? Oh, and then networking, right? So it depends, right? So you do need code to network it. So I am not super familiar with Mirror, but it sounds like it's just a code, whereas something like Photon for Unity is, I think, a service where they're going to be selling you something. And so in the process of selling you something, they actually do give you the clients for free up to a certain number. I think it's like up to 60 concurrent users, the service is free. And I'm not sure what the pricing looks like from Mirror, but it might be something similar. And I mean, if it's a master client, then you probably won't have to pay for hosting a dedicated server at all because it's just one of your players. However, right, if that player disconnects or something like that, then it could end the game for everybody, right? This is akin to maybe you've been in a Zoom meeting where the host disconnects and everybody then loses the meeting, or unless they maybe have to elect a new host before they do that, right? This is something similar going on where you have basically a privileged client that is in charge of the server authority or something like that. So yeah, it depends. I mean, Photon might host, or Mirror might host the servers. If they don't, then you would have to set up basically a remote computer like AWS, which is basically you're just paying somebody to turn a computer on somewhere in the middle of, in the middle of nowhere. And so they would have that server being turned on, and it would make the decisions for your game. Very frequent, of course, for people to have multiple servers because you pay in time for how long that message needs to travel to the server. So if you're in China and there's servers in the United States, it could take a long time for that message to be relayed. So it sometimes makes sense for you to have a server for different regions, and it's basically just a different physical computer being placed closer to wherever the client is. That way the message doesn't need to go as far. So that's sort of how that works. Any other questions you got here? So you asked about any pro tips, and then you said Unity dots. So let's go with the pro tips first. So the answer is hell yeah, sure. I mean, this is a big active field. There's a lot of optimizations that can be done. I think probably one of the most common mistakes I see, particularly with new coders, is that they say, okay, I want something to happen again and again. What do I do? Where do I put that? And the answer could be in the update frame, right? So for example, Unity, the mono behavior has a function called update, which is called remotely by reflection. And so that method update is called every single render frame. And so if they think, oh, this needs to happen again and again, I'll put it in the update function. Well, it probably doesn't need to happen every frame unless it's something graphical, right? And they even have a fixed update, which is similar, right? But that only updates every physics frame. And just for reference, the physics time step is divorced from the graphics time step because you may need to show something constantly, but you don't necessarily need to update its position as frequently as you're showing it, right? Because people can only, people don't need to, it doesn't need to happen as quickly, basically. So that's sort of a paradigm of divorcing the update function from the literal graphics update, having a fixed update and a graphics update. The reason why this is a really useful paradigm is because it applies to almost everything we do in game development. So if you have, for example, a zombie that needs to think every so often, you should ask whether or not it needs to think every frame. It's probably not the case, right? So for example, when I was working on God of War, I didn't work on that game, but I worked on that code base. I worked on the new one. They have some enemy AI, and those enemy AI don't all think every frame. You know, they certainly move that out, but they also don't all think together. What they do is they have a round robin style where they have some AI think, and then later on they'll have some different AI think, and when the old AI are ready to think again, then it's going to be their turn, and so they have a round robin system where they take turns, and so no one zombie is sort of like eating up too much processing time. So that's a consideration. So I would say that's the first thing on my mind, and then the other thing is just think about what you need to network. Okay, so it's very frequent with particularly these third-party plugins. They're going to ask you like, hey, what do you want to network for this game object? Do you want its position? What about, I mean, just think about a single component, the transform. Transform is a matrix, right? It's a 4x4 matrix. It has scaling information, rotation information, and position. So which of those are relevant? It's often the case that you don't need to network all of that. So for example, if the size of your character doesn't change, there's no need for you to propagate that over the internet. And you could save on data. If the character is in maybe it's a top-down shooter or something, then they're never going to change their Z coordinate, their up coordinate, whatever that is in your system. So that's another consideration. That doesn't need to be networked then, because it's not going to change. It may not be relevant for you to know what rotation a tower is spawned in, right? That's another consideration. So there's a lot of data that may not need to be translated. So that's what I would think about. I would think about how frequently do you need to translate it, and how much do you need to translate. And when I say translate, I mean send it to the server and put it back down. The process of having people aware of a certain aspect of data is called replication. So if you are going to be tracking the position across the server and the clients, that's called replicating that data. So that's the keyword you might be looking for. Okay, so that is some of my advice on that. And then the last question you had is Unity dots. So I did give this a little Google, but I'll pull it up again. Unity dots. What is that? So Unity dots is a multi-threaded data technology to take full advantage of multi-core processors. So the short answer is no. You don't need to learn about this. It's completely unrelated to what you're doing. However, I think it's a useful, I'll still explain what it is and how it fits into the bigger picture, okay? So how does this work? So let's say a computer has a processor, okay? Your computer, let's say it's a processor, and a processor is a decision maker. Similar to the server, how the server is a decision maker, but we'll get back to that in a second. So your computer makes decisions, and it can perform computations. So let's say, for example, you say to your computer, what is 5 times 10? And the computer knows, oh, in order to calculate 5 times 10, I need to do 5 plus 5 plus 5 plus 5 plus 5 plus 5, a total of 10 times. And that result is your answer. But for a complicated problem, it might be faster to split it up into smaller, simpler problems and give it to your friend to do, right? So this is, so in this case, 5 times 10, that's the same as 5 times 5 plus 5 times 5. And so you could split this problem up, and someone can do 5 times 5, and someone else can do 5 times 5, and then you can add the result, okay? So this idea of having two different people do work together for the same problem and then combining the results, this is basically the concept behind multiprocessing. Well, there's one other factor, but we'll talk about that in a second. So computers these days have multiple processors, and so the benefit of that is you can split up the work, like we were saying here. And they also have, particularly, they have processors that are specially designed for matrix multiplication, and that's of course the role of a graphics processor, a GPU. The whole reason you want a graphics processor is just so you can offload work, particularly matrix multiplication, to the graphics processor. And it could be really fast at doing that because it's highly optimized for those kind of computations. So that's the idea. And so it's the whole idea, well, so the limitation is Unity by default is not going to use multiprocessors. Unity by default is a single threaded system, which means that at any given point only one section of code is being invoked. And so there is a great value to that, right? It drastically reduces the complexity of a system. So for example, if you have two different pieces of code that are running at the same time, they could change something and that could affect the other one running in a negative way. We can have something similar to where I place the tower and Dan place the tower at the same time. We have a bit of a collision there, so that could be a problem. The other situation is called a deadlock. And what happens there is if you have two different processes, one can say, let me wait for the other guy. And one can say, hey, let me wait for the other guy. And these guys can both be waiting for each other forever. And that's considered a deadlock. It's a terrible situation, and it is one of the main concerns when we're doing multiprocessing. So that's what multiprocessing means. It's not really related to networking, but you can see how there's parallels, where in a server we have different clients that we have to worry about both seeing this a view of some shared resource. The same thing is sort of happening with multiprocessing, where we have two different processors, which could be computing information that relates to the same thing. So there are parallels, but it is essentially a different problem. Then the other thing is multi-threading, and so this is we're getting into the weeds here, but a single processor might begin a process where it needs to wait. So for example, it might wait for the user to press a button. And so if the user is waiting for if the program is waiting for a user to press a button, it might then say, hey, I could do something else at this time. I don't need the entire processor to come to a halt because we're waiting for the user, right? Because you only got so many processors in your computer anyway. So that is where we introduce this concept of threading. And so a processor can have multiple threads running. And so similar to the round robin style we talked about with the God of War enemy AI, it can go to the different threads and it can say work, work, work until either I think it's time for you to stop, or if you ask me to wait, and then I can go to the next thread and have it to work, 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 and then stop or ask me to wait. And so that's really useful, particularly when you have multiple things running. So for example, well, let's say you have 10 processors on your computer, okay? And you have 10 tabs open in Google Chrome. And let's imagine that it's set up in such a way that each tab is a separate process. Well, you're probably only going to be looking at one tab at once, unless you've got like multiple screen displays. And so it doesn't make sense for the entire processor to not be used at all just because you're not looking at the tab. Instead, we could put it on a thread and like have it sleep, and then we'll wake it up when it's the right time. And so this topic of computer programming is called concurrency. And so it's a really great topic. There's a lot of awesome examples and stuff to research here. One of the great examples, I think it's from MIT, is called the dining philosopher problem, which is a situation, I think, where we have a deadlock situation where one person is waiting for a thread and then another thread is waiting for the resource, and they all stop waiting, and then your computer completely stops and it's a standstill. So you can look up the dining philosopher problem if you want to learn a little bit more about multiprocessing, which is a topic that I think, or concurrency in general, which covers topics like multiprocessing and multi-threading. So I think that answers your question about dots, totally unrelated to the other questions. Is it something you need to worry about? No, not yet. Not yet, but maybe in the future. Okay, so I think I answered all your questions. Thanks, Dan, for sending them in. Good luck on your game. Definitely let me know how it goes. And if anybody else is watching and you have a question about your game, please send it in. Leave me a comment or send me an email, and I'll get back to you as soon as I can. Thanks.